Remember, vectors are lines with arrows, and one of the most common form of vector are position vectors. That means it's a vector that starts from the origin O. The common notation for this small letter a is the vector OA. So the position vector OA usually denotes the vector A, and the position vector B is given by the vector B. Remember to underline that. The two bars beside A and beside B, that's the modulus of the vector or the magnitude. So the magnitude of OA is simply OA, meaning it's the length of the line, and the magnitude of the vector OB is simply OB, and that is the length of the vector line. So think of this, we have to find the angle between the vectors A and B. So it means if you have vectors like that, this is OA and this is OB, you have two vectors, you have to find this angle. That's the idea. The next one is the vector A minus B. Vector A minus B is simply the vector BA. That's known as the position vector rule of finding vectors. So it means OA minus OB. So the vector A minus vector B, meaning the position vector differences of OA minus OB, that is the vector BA. When we want to find a particular vector, is the difference of the position vectors, and the modulus of BA, it's simply the length of the line BA. Since we know that the modulus of A is 4, we can say the length of OA is 4. The modulus of B is 4, the length of OB line is 4. And the vector BA, it has a modulus of 7. So now we have a triangle and we can use the cosine rule for finding the angle, and the cosine rule states that cosine rule of the rule of cosines, the rule of cosine, it says that if you have a non-right angle triangle, we usually use this for non-right angle triangles, if this length is A and this length is B, the included angle is theta and the opposite side is C, then the cosine rule states that cos theta equals to a squared plus b squared minus c squared divided by twice ab. So that's that. So we can now find this cos theta, let's mention in triangle OAB, cos theta equals to 4 squared plus 4 squared. Remember, we have to take the sides that make up the angle first, minus 7 squared divided by twice into 4 into 4. So this turns out to be, when you do calculation, it's a good idea to sum of the calculation in your head and the remaining in the calculator. You don't have to punch out everything in the keys of the calculator. So 4 square is 16 plus 4 square is 16. 16 plus 16 is 32 minus 7 square is 49. So that's minus 17. Minus 17 divided by 2 4s are 8. 8 4s are 32, so minus 17 by 32. Therefore theta equals to cos inverse of minus 17 by 32. You can either leave the answer in degrees or radian. I'm leaving the answer in degree. So cos inverse of minus 17 by 32, and it turns out to be 122 degrees. In this question, we have the position vectors of A and the position vector of B. That means OA is 3i plus 2j minus k. This is the position vector of A. We can also call this simply A. And the position vector of B is also given, starts from O. So this is 5i plus 6j plus 5k. Remember to underline the vector, that is very, very important. This can also be known as small letter b in shortcut. Now we have this information, and the next information that we have is some sort of a ratio. We have AP equals to 3BP. So that means if this line is AP, it is made up of three of these. In other words, if you think of this ratio as AP divided by BP, then it would be 3 by 1. If I just cross multiply this, that means the entire thing AP is 3 and BP is 1. That means this makes it 2. So if you think about it, it is made up of AP, the entire portion, and that is 3 parts or 3 portions, and BP is 1 portion, then the remaining AB should be 2 portions. So this is the important concept of ratio rule for that. For example, if you're asked to break down 100 taka into 2 portions, 2 is to 3, there are altogether 5 portions. So there are 2 portions over here and 3 portions over here. So there are 5 portions. So when you think about it, then what would be each portion? Then each portion would be 100 divided by 5, which is 20 taka. So 20 taka would be each portion. So if this person gets 2 portion, that person would get 20 taka plus 20 taka. So it would be 40 taka. And this person will get 3 portions, which is 20 plus 20 plus 20, which is 60 taka. So that's how you divide. A generic rule for this would be, if you have to divide a total x is to y, a total, suppose if it's a length of a line AB, then the portion with x would get x divided by x plus y into the total length of AB, and this would be y divided by x plus y into the total length of AB. So that's how the ratio works. So let's do this one here. A diagram always helps. So if you know what OA and OB is, if you draw the diagram like this, this is OA and OB, this information is given. And we also know that if you have AB produced over here, then we're going to get a point P. So we can join here OP. So diagram really helps. I recommend you draw the diagram all the time. So the first thing, in order to find, what we have to find is the position vector of P. So we have to find OP. So let's start. So finding OP, we can use the position vector rule, which is AP equals to OP minus OA. The position vector rule states that if you want to find a vector, for example, PQ, it means the vector has a beginning, which is known as the initial point, and an end, known as the terminal point. So the vector PQ would simply be position vector of the terminal point, OQ, minus position vector of the initial point. So that's the position vector rule for finding vectors. So in this particular question, we have to find OP. So OP would be simply, if I send this OA to the other side, it would be OP equals to AP plus OA. Now how do we find AP? We know this ratio. If AB is 2, this is 1. So if we want to find AP, we can simply find it using the ratio rule. So the ratio rule can be used like this. For AP divided by AB, so AP, the whole thing is 3 and AB is 2, we can write, therefore, if we cross multiply, 2AP divided by 3 equals to AB. So that is the ratio. AB equals to 2 by 3 of AP. When we find the ratio of lines, for example, AB is a line, length of a line, and AP is also referred to as the length of a line, is the same as the ratio of the vectors. That means, therefore, if you want to find AP, it would be 3 by 2 of ABs. From ratio, we can also find vectors. So since this refers to the length of the line, and the ratio of vectors and the ratio of lines, they are the same. So we can write, therefore, the vector AP equals to 3 by 2 of the vector AB. Now we already know the position vectors of AB. So using the position vector rule, we can find AB equals to OB minus OA. And that turns out to be 3 by 2. So OB is given over here 5i plus 6j plus 5k minus OA is going to be, now since there is a minus over here, I recommend you give a bracket, because if the bracket opens, it's going to be different in sign. This bracket closed. Now if we start simplifying, it turns out to be 3 by 2. 5 minus 3i, if you open the bracket, it's going to be 2i, plus 6j minus twice j is going to be 4j, plus 5k minus minus plus k is going to be 6k. Now what we can do is, we can take the 2 common, and it would turn out to be 3 by 2 into I plus 2j plus 3k. And this 2 and this 2 cancels. Now we can write AP equals to 3i plus 3 2s are 6j plus 3 3s are 9k. So that is AP. Now we can put the value over here and find the position vector of OP. Hence, OP equals to AP, which is 3i plus 6j plus 9k plus AP. So AP is, this is OA. This is OA. OA is 3i plus 2j minus k. Since it's already plus over here, I don't have to bother this with a bracket, because I know the sign would be the same as before. If it was a negative, I highly recommend give a bracket, otherwise there might be mistakes. So 3i plus 3i is 6i. 6j plus 2j is 5. 8j plus 9k minus k is 8k. So that's it. This is the position vector of OP. In this question, instead of vectors, we have 2 points. Each of these points have 3 dimensions: x coordinate, y coordinate, and the z coordinate. So the rule for finding the length of a line or a vector is, if you have coordinates x1, y1, z1 and x2, y2, z2, then the length of the line would be AB square root difference of x whole squared plus difference of y whole squared plus difference of z or z whole squared. That's it. And the square root would be above the entire thing. Now when you find vectors, in case of vector, it would be the vector AB OB minus OA, and OB is, if I write in the column vector format, the x coordinate would be here, x2, y2, z2, minus the position vector of A would be x1, y1, z1. That simply means AB would be x2 minus x1, y2 minus y1, and z2 minus z1. In question number A, this particular question is asking for find the modulus of the vector. Now, if you have a vector AB in the format of xi plus yj plus zk, which can be written as column vector format x, y, z, then the modulus of that vector would be square root coefficient of I whole squared, coefficient of j whole squared, and coefficient of k whole squared. That's it. Now in question number A, we have to find the modulus of the vector AB. That means the length of the line AB. Remember, modulus of a vector is the same as length of that line. So we can simply write AB equals to square root. So the difference is going to be, remember, this one is A, this one is B. So we can write difference of x 3t minus 2t whole squared, difference of y 2t minus 10 whole squared, difference of z 5 minus 1 whole squared. So this turns out to be 3t minus 2t is t, so t squared plus 2t minus 10 is a minus b whole squared, so this is going to be a squared. So 2t squared is going to be 4t squared minus 2ab, 2 to the 4, 4 tens are 40, so 40t plus b squared is going to be 100 plus 5 minus 1 is 4, 4 squared is 16. If we further simplify, this is going to be t squared plus 4t squared is 5t squared minus 40t. 100 plus 16 is 116. So this is how we can directly do it. If you want to do it in another way, you can do it in this way. We can find the vector first. The vector AB equals to OB minus OA. So this is alternate method. Okay. So what's going to happen over here is the vector, position vector OB is 3t, 2t, 5 minus the position vector of OA is 2t, 10, 1. And when we subtract this, so this is going to be 3t minus 2t is t, 2t minus 10 is 2t minus 10, and 5 minus 1 is 4. So modulus of that is going to be, so t squared plus 2t minus 10 plus 4 squared. You can do the sum in either way, it doesn't really matter. Now take a look at question number B. Question number B is completely different. It does not deal with vectors, it really deals with coordinate geometry. It deals with maxima and minima. So what they are saying is that by differentiating the length of AB squared, find the minimum value of t. When you have a question like that, what you do is, let me write question number B. L squared equals to 5t squared minus 40t plus 116. So now we can consider the entire length of the line. We can consider it L, and if you remove the square root as they suggested, it becomes L square. So this is a parabola. It's a Cartesian picture. It's a parabola like this, and we have to find the minimum value, meaning the turning point. So this particular question is completely differential calculus and coordinate geometry, and you have to think of this as a different question altogether. So what we have to do here is we can write the derivative. So at the turning, or let me write minimum point or minima. At the minima, derivative or gradient or rate is 0. Therefore, if we differentiate this, it turns to be 5 to the 10, 10t minus 40, this is 0, equals to 0. So this is the derivative. This is the derivative what we are finding, and from the derivative we can find the value of t. So the value of t turns out to be 40 divided by 10 equals to 4. Now how do you know this is the minima? Although they did not mention that you have to check, it's a good idea to show how do you find that. That's the second derivative. So you write the second derivative. So the second derivative, the first derivative is this, 10t minus 40. Let me write it down over here. If think of this as a curve. If 5 t square was a curve, so let me write 5x squared minus 40x plus 116. I'm writing in the Cartesian form of x and y. So you found dy by dx, and dy by dx was 10x minus 40. Now you have to find the second derivative, d2y by dx squared, which would be simply 10. So that means second derivative, since second derivative is positive, meaning greater than 0, it is minimum, meaning t equals to 4 will give you the minimum value. That's it. And the next question is usually finding the length. So find the minimum value of this LAB. So what we do over here, when t equals to 4, then L square equals to 5, 4 square, putting it over here, minus 40 into 4 plus 116, and this turns out to be So 16 5s 80 minus 14 to 4 is 160 plus 116, and that is 36. So this is the minimum value of L squared. But the question was find the minimum length. Hence, minimum value is, it should be square root of 36, which is 6.